backed by Japanese technologies and both professionals, R&D engineers and competent technicians. And when you come to us, we'll work closely with you, making sure you get the most value out from Ebara products.
EPM aims for greater heights as we look forward and go beyond expectations to meet customer satisfaction.
Okay. Good. This one, what do you mean? Equipment should be programmed to 100% concurrently maintainable. So referring to duty chillers, right? Referring to duty chillers. You're referring to duty chillers.
Good afternoon to everyone. Welcome to our Ebara Pump webinar series. I hope you are doing good during this MCO period and also keeping healthy.
So,
Thank you to every one of you who have allocated your time to tune in for this webinar. And we have received very strong participation from many of our customers as well as companies and like M&E consulting engineers, developers, contracting companies, as well as other engineering companies. So we are very happy to organize this for the benefit of many out there who wants to know more about pumps. Now, we ran a series of webinars during MCO 1.0 last year, in which many of you all who have participated, and these new MCO 2.0 sessions will cover a little more information and detail on pump knowledge. And of course, we hope that these sessions will not only be beneficial to gain some understanding, not just about pumps, but also on how it can help you to select and design the right equipment for your application. A little introduction to myself. My name is Eddie Lee, as you can see from the picture on the slide. And I'm the Business Development Manager for Ebara Pumps Malaysia. I've been with Ebara just about a few years, but not so new in the pump industry. I joined my first pump company around 24 years ago, to be exact, and have slowly moved up to this in this industry until today. But have also worked quite a few years in different roles in other engineering industries, both in Malaysia and overseas. So with me today is my co-host, Miss T, who will be my assistant for this webinar. And one of her main tasks will be to assist you if you have any login problems, and also consolidate all your questions at the end of this session so that we can answer them. So if you have any questions during the course of this presentation, please type it into the chat column at your Zoom interface, and at the end of this session we will consolidate all these questions and go through it and try to answer one by one as much as we can. Now, a little introduction to our Ebara EPM Pump Academy. EPM stands for Ebara Pumps Malaysia. We set up this academy, both virtual academy as well as a physical academy or a training facility, to bring technical knowledge of pumps and fluid applications to the industry. So it is our educational center for all pump related information. So we regularly conduct training and seminars for various group of customers, from government to statutory bodies like Icelango and many of the water authorities, as well as many of our project customers that purchase our pumps. So it is a platform for us to enhance the understanding of pumps and its application for all our customers.
The panel will still need, but the chiller will not.
So, once again, what is the objective of this webinar? Well, we know that many of you here are from the construction industry. So from our attendee list, we see many developers, M&E consultants or consulting engineers, contractors, plumbers, and specialized engineering companies such as those from the water treatment and facilities management industry. So in all your projects, you will need to use pumps for various applications. So we want to take this opportunity to impart very specific and useful pump knowledge to you, which we believe can be beneficial in your course of work, as well as keep you updated on the latest pumping technology today. So with this in mind, we have arranged this webinar series to be in 3 parts so that we get a good coverage of the applications in the building industry, where this whole webinar series is themed after. Now you can see a list of the topics we will have for the next few weeks, at least for the month of February.
So maybe you have to
during this MCO period. And today, our topic, you can see from the first one will be the right pump for the right application. We'll take a break for Chinese New Year next week, but the following week on 19th of February, Friday, we will have efficient pumping methods for high-rise buildings, where we will cover all the techniques of having a good pumping system, especially for high-rise. And topic 3 will be on good installation practices and even noise control solution in building. And that will be almost at the end of February, on 26th of February. So same time, Friday, 3 to 4 p.m. And I promise you that if the MCO is extended, then we will continue to have these webinars to keep you all at least
actually we don't
informated and benefited from this whole series.
11.
Okay, so once again, if you have any questions related to pumps or our products or our company or anything that you wish to know about Ebara, you can just type it into the chat column on your Zoom interface, and we will consolidate all these questions and try to answer them at the end of the session. Okay, so just fire away with all the burning questions that you have.
Okay.
Okay.
Yes, I think you can do something.
Okay, now the theme of this 3-part webinar will be on achieving efficient and quality pumping systems within building services and commercial construction projects. Now this 3-part webinar will cover mainly those applications related for the building services. So for those who are more engaged with, for example, factory applications and industrial applications, or even those with water supply, well, we will have future sessions related to that. So these 3 sessions will just concentrate mainly for the building services. Okay, so we know this building industry use a lot of pumps for moving water in various applications. So we know that there are many of you whose work are related to this industry. So today's topic, the right pump for the right application, will cover some fundamental understanding on the type of pumps used in building services. Okay, so in this topic, we will cover some of the most common type of pumps used, and also understand the construction of the pump and some of its features and advantages, and why these pumps are used for that particular purpose. So very quickly, before we go into the details, where are pumps used within a building? Now, most of you know that there are 5 main services within a building. And where are they? One, of course, the most common would be in plumbing services and sanitary services, That means mainly dealing with water and wastewater that's coming in and out of the building. And fire protection systems, yes, in any fire systems, pumps will be used to boost the pressure of the firefighting or the sprinkler or the hose reel or the wet riser systems. In air conditioning systems, if you have a large building, then there will be chilled water systems, and you will have bigger pumps to pump chilled water through these AHUs and the air conditioning, the general air conditioning system. So we'll talk about some of these pumps in these air conditioning systems. And not forgetting also, in landscaping, water features, and irrigation, also there'll be some pumps that are used in this application. So, cold water and plumbing services, as most of you all will know, there are mainly two types of pumps. We have what we call the transfer pumps, which are to transfer water from the suction tank to the storage tank, usually on the roof or on an elevated area of the building, so that water can flow down. And you will have the booster sets. You can see from here, booster sets like this for pressure boosting to fittings such as the toilets, bathrooms, kitchens, and all the water consumption areas. So this is an installation of what we have done in KLIA for a chilled water system. And in a large building like KLIA, typical split case or end suction pumps are used to pump large amounts of chilled water through the chillers. And even in some cases, district cooling systems like those that you can find in Putrajaya and Cyberjaya with many high-rise buildings. Not forgetting fire. You can see here an installation for a sprinkler pump system. This was taken in one of the MRT stations in town, in TRX. And not just for sprinklers, but also wet risers, hose reels, hydrant pumps for all around building protection against fire. And these pumps need to meet certain guidelines, safety guidelines, like from BOMBA, as well as some of y'all are also designing fire pump systems using the LPC standard, and some even with NFPA and FMUL listed pumps. So we cover a very big range of fire pumps within the Ebara range. And not forgetting, whatever that comes into the building must come out. So that's where the function of the sanitary and wastewater services are for, and that's where the submersible pumps are usually used. And these are also called sump pumps, as they are usually installed in a sump like what you see in a picture here. And finally, buildings need beautification as well as landscaping to provide a healthy and holistic environment for its occupants. So it's not just bricks and concrete. So in many cases, water features, landscaping, all these green themes require good pumps to ensure that the plants are irrigated and water is also being circulated continuously. So coming to that, now the top 5 most common pumps in building services, which we are going to go through today, and this will be very good for your general understanding. Number 1 will be the vertical multistage inline, very commonly used for many pressure and pressure boosting and water transfer. We'll talk about that. And then the end suction pump, you can see here, also very common for fire, for air conditioning systems. Horizontal split case pumps, usually in the chilled water systems. Booster systems, a package system like this, and the submersible pumps. So we will go through a little bit more in detail on these pumps one by one.
before 45
Once
minutes,
again,
so fast.
if you have any questions at all, just type it into the
No,
chat column,
basically,
and then we will answer it at the end of this
如果我们是跟着这样
session.
子来跑的话，其实是很快的 technical
是咯
clarification
是咯。
Okay, so let's start with the first pump in the series, and this is what we call the vertical multistage inline pump. Now, most of you see the outside of the pump or the physical look of the pump, but very few actually get to see how the inside of the pump looks like. Now, the vertical multistage inline pump is one of the most popular type of pump used in a building. And this pump has many good design features and is excellent choice for water transfer as well as pressure boosting to toilets and fittings. Now, as you can see from the name, it is what we call a multi-stage design. That means it's made up of not only one single impeller but many stages with an impeller in each stage. So if you can see from the picture here and a drawing here that in this drawing there are 3 stages or 3 impellers. So the water will come in from here and it will be channeled to the first impeller, or we call it the first stage, and this impeller, when it's rotating at the speed of the motor, usually we call it 3000 RPM or 2900 RPM, it will actually impart a centrifugal force to the water, and that water will be channeled to the second stage. So in each stage, it will build up pressure of around 1 bar or so, okay, plus minus, and then it will move to the next stage, and the next stage will impart another 1 bar pressure by the centrifugal action, and the third, and so on. So then what happens is the water will now be channeled between the chamber of the pump and the outer casing out to your outlet pipe. So you can see from the construction here of how the pump is like. The motor will be on top and the coupling between the motor to the pump. And on top of the pump, usually you will have a mechanical seal. There are many types of seals for this type of pump, but the most common will be a cartridge seal. Then you have the shaft and you have the chamber and the impellers, and all these are rotating at 2900 RPM, the shaft and the impeller, okay? So with that, it is able to build the pressure of the water when it goes in and out. So basically, for such a pump, the higher pressure you need means there are more stages. Okay, so you can see some pumps are very, very tall, and that could mean that it is a very high pressure pump. Now, one of the advantages of this pump is that it can deliver more than 20 bar at its maximum stages, depending on the model chosen, and is suitable for even the highest building all over the world. Okay, so in many high-rise towers and buildings, this pump is used for water pumping right to the top of the building. So you can see from here the range that we have, and easily from the smallest 1 meter cube an hour all the way to 100 meter cube an hour in different models, and up to 250 meter head. Now, I mentioned some of the advantages of this pump. So space saving, you can see because of a vertical design, the pump takes very little floor space, and that's good for today's pump rooms, as many developers are squeezing pump room space to be very small. So this type of pumps will be very ideal. Very quiet running because of the vertical design and the way it is constructed. It does not have any alignment issues. It is perfectly aligned most of the time, and that means that it does not create a lot of noise compared to, say, a horizontal pump like an end suction or split case pumps, which can generate a lot more noise, especially if the pump is out of alignment. Very clean materials. Normally, these pumps are made in either fully stainless steel parts, and maybe just the top and the bottom cast iron. Normally for cold water application, we have stainless steel 304 and just on the top and the bottom cast iron, but in many industrial applications, it will be completely fully stainless steel 304, which means that any parts that are in contact with water is 304. So it prevents rust and brown water as from the pump. And most importantly, a maintenance-free design. You hardly need to maintain these pumps in any way. You don't need to do alignment. You don't need to do any form of bearing greasing and so on, because these pumps are built very, very user-friendly and requires very little maintenance.
Run through your first interview based on your submission.
Now,
to us,
I want to just highlight one of the very important feature of this pump, which is often not mentioned by any brand. And this is what we call the problem of trust. Now, first, before we get into this subject, let's have a quick quiz, okay? So we will grant a prize to whoever that can answer this, and that prize will be sent to you. Don't worry about it, okay? So the first quiz of the day.
Not previously.
Now,
a few days ago we sent
who can anyone guess the person or the picture that is on the slide? Now,
there are a few documents inside with the sequence operations.
Whoever you can guess, please type it into the chat column, and we want to see whether you can get the right answer. Okay, we have some there. Da Vinci.
So,
yes, you got that right. I saw the answer now. Very smart. So, Mr. Ashok, congratulations to you. Oh, Mona Lisa. No, she's not so pretty.
We want you.
Okay, someone got the answer right. Mr. Ashok. So, please later give us your email and your company detail, and we will send you a nice gift. Now, why Isaac Newton? Okay. Now, you remember this, and that's what he's famous for. And he found what gravity was. And Isaac Newton was an English mathematician. He lived around 400 years ago. Now, one of the most important discovery that he made was what we call the laws of motion. And of course, many of your science and engineering students would have learned about this. So he made 3 laws of motions which has stood, or rather not just stood the test of time, but rather forms the basis of all equipment, as well as anything that moves today, whether you are designing equipment or you are building a rocket to space. You have to follow these 3 laws of motion, right? So first, it states that every object persists in its state of rest or uniform motion in a straight line, unless it is compelled to change. So that means as long as an object is moving, it will continue to move until other forces affect it from moving. It could be friction, it could be wind, it could be anything else, okay? And the second one is force is equal to the change in momentum. And this is one of the famous formula where force equals to mass times acceleration. Now, what we want to talk about today is the third and very important law, which is for every action, there is an equal and opposite reaction. Now, not just in physics, but also in any human relationship, right? There's, for every action, there is an equal and opposite reaction. So that can happen to boyfriend and girlfriend, husband and wives, and so on. So you know what I mean, eh? But
in terms of ESC,
now what we want to apply here to highlight is how does this apply to the issue of trust in pump. Now first, let's understand what is trust.
Where we will require you to...
Okay.
Who is Vincent?
Let me see. Okay, so if you look at a plane flying, then you will have four forces acting on the plane. So the lift is what is causing the plane to be lifted, and this is caused by the power of the engines as well as the wings. And of course, there's the force of the weight of the plane that's acting downwards. And when the plane is flying through, the engines are causing or powering up the planes, and the thrust is there, but the wind of course causes a drag. So what we mean by thrust here is the force that is a mechanical force generated by the engines to move the aircraft. So you can see that that with the power of the engines, there's a thrust that caused the plane to thrust forward and fly forwards. Now, same principle with a rocket. So when a rocket is shooting up to the sky, then you have a lift, you have a drag, the weight is acting downwards, but the thrust is the one that is causing the rocket to fly upwards. Now, in the same way, where this law applies, whenever there is an action, there is a reaction. But if we come back to the subject of a multi-stage pump, now a multi-stage pump will have a lot of what we call an axial thrust. Now, I mentioned earlier how these pumps operate, where water goes into the pump and is built, the pressure is built up in each stage. Now, if you look at the stage of each pump, you will see that the red zones are what we call the pressure distribution. So this is the bottom of the impeller where the water comes in. So whenever the pressure builds up to the next stage, there is a higher pressure on top of the impeller compared to at the bottom of the impeller. So you can see the area of the zone. There's more pressure on top than the bottom. So the imbalance of pressure is causing a downward thrust because the pressure here is higher than the pressure that is at the bottom. Now, what happens is when you multiply this imbalance by maybe 5 or 6 or 8 stages, then what you get is a very unbalanced thrust acting downwards to the pump. Now, the problem is that this thrust has to be taken up somewhere, and the only way that this thrust will be taken up is either through the foundation of the pump, but because of the force, the motors will have to absorb some of this thrust. Now, that is why a very important fact is that for a multi-stage pump, normal motors cannot be used. When I say a normal motors, it means the standard motors that you buy from the supplier. You will need a motor that have a special thrust bearing, and this means more cost. Now, what is the solution then? What is the solution to counter thrust? Now, of course, Ebara being a Japanese manufacturer, and the Japanese have always been very innovative in finding solutions to counter any problems. And you can see examples of the many Japanese car brands on the road, the Toyota and the Hondas and the Mazdas, and they are mostly problem-free. So that's a testimony of the Japanese technology. And even in everyday life, like even our homes or even in what we wear, the Japanese always have a solution. If you don't believe, just walk into any Daiso shops and you can find all kinds of unique solutions for every problem in your house. Even all the funny things that they have, no other shops have. And those are usually designed to solve some issues in your house. And even if you are running out of ideas of what to wear, go to where? Anyone has an idea?
I need you to give me a proper proposal.
Anyone?
Can you do
go to Uniqlo? Yes. So I don't know, many of you do not know that Uniqlo is actually a Japanese branded clotheswear or apparel shop. So in Uniqlo, you can find all types of clothes that you like, whether undergarments, overgarments, underwear, socks. clothes, whatever.
The next
So
item I want to touch on
we
is
can
your
trust the
sequence.
Japanese to come up with
Like I mentioned
unique
just now,
solutions
the
to
CPOs,
all problems.
You have to do the programming.
So in this case,
Suit
Ebara has
your
also
sequence
found the
operation, the
solution
document that I sent
to
you.
counter
You
thrust.
received that document?
Now, what is the solution? Anyone has any good ideas?
It's attached in your invitation.
Can I get a quick type in the chat? Any engineers out there who can provide the answer to this?
Yeah.
No. Very quiet. Okay,
So
then I
that
will show
document is very
you.
important, for you
So
to
it's
do
in
your
the way of the ninja.
Okay.
Okay.
So far, anything else you want
So
to
what
touch
do
on
we
the
mean
commercial side?
by
I can tell you your
the
price
way
now
of
is
the
still,
ninja? Now the solution
not
is
very
actually
good
in
because you
the
have to include
shuriken
certain items
impellers.
like, for example,
And these shuriken impellers, you can
I'm not
see
sure, have you
from
included
the
CPOs?
design
No,
of the impellers, it has been shaped to dramatically reduce
Okay, you
the
have to put
axial
that in
thrust
also, so
caused by
that
the
will
pressure
bring the
imbalance
price even higher.
between the top and bottom. Now, how is that achieved?
So,
Okay,
on the
if you can
commercial
see
side,
from
you might
here,
have to relook
you will
into it
see
lah.
that in the earlier picture, a conventional
We should have this
impeller will
document.
have
Actually, everybody has it.
unbalanced pressure between the top and the bottom, but with the shuriken impeller, it is able to reduce the pressure at the top with this special shaped impeller surface and allows the pressure to be equalized between the top and the bottom. Very, very smart move. So you can see the design of let's say a smaller model and a bigger model and how the shape of the impeller is. So only Ebara has this design method for all the impellers. And if you can see from here, what happens is that when they compare the thrust forces between a normal impeller and in the blue one, a shuriken impeller, you can see the difference of the axial thrust is, or rather the axial thrust is greatly reduced because of the design of this impeller. So this is one of the very good design advantage that no one has. Now, from vertical multi-stage pump, we move on to the next pump, which is the very common pump, which is what we call the end suction pump. Now, this pump is one of the oldest pump design in the market. The design itself is more than 100 years old, but it has stood the test of time for many reasons, both from cost point of view, durability, as well as the ability to have a large flow range within a pump model. Now, this pump is typically what we call a cast construction. Okay, unlike a vertical multi-stage pump, which is made out of pressed steel, an end suction pump is made mainly casted from cast iron to achieve very strong and robust casing. And this is able to withstand high pressure and dynamic stresses. Now, you can see from the cutout of this pump, the elements are pretty simple. You have the pump casing in front, and there's always a bearing housing at the back of the pump, and that's where the bearings are. There are a set of two bearings that supports the shaft, and the impeller is tied to the shaft at the end. And this part is where the liquid of the or the water is contained, and the eye of the suction comes in, the water comes in through here, and as the impeller is churning, it actually creates that centrifugal force and expels the water out at a higher pressure. And a mechanical seal seals the wet part against the dry part. Okay, so the construction is pretty simple, and with that you can have a pump that is able to have a very big flow range within a certain, let's say, model or so. And one of the good feature of this pump is that it can be driven by various types of prime movers. What I mean by that is that not only motors, but also by an engine. or even if you are in a very let's say that area, then it could even be by a belt and pulley system. So in fire, you will have this same pump that can be driven by either a motor or engine driven. So that's one of the advantage of an end suction pump. Now, for a pump with such an old design, how can engineers improve it? Now, usually when something that has stood the test of time, like a pump like this, which has a design of more than 100 years old, it is very difficult to improve it as it is already a proven design. But yet, the engineers at Ebara, the Japanese being Japanese, they can always find new ways to improve it. And this is in the form of what we call CFD, or computative fluid dynamics. So what is CFD? I think, again, many of your engineers have heard about this software, and even some of you may be using it. But CFD is basically an engineering tool used to simulate the action of thermal fluids in a system. And it's used by many industries in their development work to analyze and to optimize and design things that actually have to either move liquids or cut through liquids or air. So CFD is a very important tool for this type of equipment. So this is where, by using advanced CFD methods, Ebara has improved a 100-year-old pump design to improve its hydraulic efficiency, and with that, it is able to improve the energy consumption easily by 3 to 5% from a normal pump that has an older design. And in some cases, it can even result in a smaller pump for the same Q and H, flow rate and the head. So the new Ebara GS series has a very big flow range of up to 350 meter cube an hour, and even heads up to 150 meters, and has a very good, what we call a BPO, back pull-out design, which allows easier removal of the pump rotating parts here without affecting the pipe work. So in cases where you need to take out the pump for maintenance or to inspect the pump, you can just remove the pump body without affecting the casing, so that the casing and the pipe do not need to be removed. So it's a very good design. And not only that, but it is designed to what we call an international standard EN733, which allows any pumps that are conforming to this standard to be replaced easily. So that means if you have another pump that has this same standard EN733, then you can just take out that pump and replace it with this pump, and the pipe and the connections will all fit properly. So that's what we call interchangeability of pumps. So these are some of the good features of this 100-year-old pump, which has been renewed. Now, the next pump that we will talk about is what we call the split case pump. Now, you often have heard this term split case. Now, basically, as you can see from here, what it simply means is that the casing of the pump can be taken out, or rather split by half. Not by half, but rather the top part can be opened up to get access to the internal elements of the pump. Now, split case pumps are usually for medium to large flow applications. So it's usually used, like I mentioned earlier, for bigger flow applications like centralized air conditioning systems, pumping large amounts of chilled water through the chillers. And in such a case, the flow rate is always more than, let's say, 2 to 300 meter cube an hour. And even in some district cooling systems. So again, coming to the construction of the pump, it is a very robust pump. with a very durable construction.
So the
And
price now you
like
offer
the end suction
1,000
pump, it is
Canadian,
manufactured
is
by
that
a
oil based
casting
on,
process.
oil-free?
And the cast pump casing usually like this,
So
made
I
out of
believe
cast
that
iron,
it comes with
and
a
the
heater
main
also in the
impeller
chiller that is built in, right?
could be from bronze or even in some cases
There is
stainless
a
steel.
heater inside,
And this pump, one of the unique features is that it has a
any battery provided by
double suction design. Now, what do we mean by a double suction design? It simply means that the water, when it flows into the pump, is able to split into both sides of the impeller, because the impeller allows entry of water into
that means your
both,
offer this time around, you
both
didn't
of
put
its
in any
sides.
battery lah,
And with
correct?
that, as it rotates at its speed, then it will
because
generate
in
that
our
centrifugal
last
force.
clarification, we did
So,
mention to you that
in such a design, it creates a much more
if your
balanced
chiller is the oil-based chiller,
hydraulic
the
as
heater
well
and
as
also
dynamic
your
forces
microprocessor
within the pump.
and also the
And
C-force will be backed up
because
by,
of that, usually
our battery
split
lah.
case
We have a
pumps
UPS to
have
back up
much
all this
higher
thing.
efficiency,
You just have to
higher
terminate the
efficiency
wire to your system.
compared to, let's say, an end suction pump
Okay.
for the same
So
flow
I
rate
just
and
worried
head.
that if you include the
So,
price, you can take it out lah.
if you see also from here, one of the very good construction is that the shaft is supported by both bearings on both sides, or rather bearings on both sides of the pump. So it is a very balanced construction, and also mechanical seals on both sides of the pump. So that's why split case pumps tend to have much higher efficiency compared to many other type of pumps. So our split case pump also has been redesigned with new volute design using CFD, and now in a lot of applications we offer with either IE2 or IE3 motors for improved energy savings. And not only that, but as mentioned before, with the double suction, double mechanical seal and double bearing, it is a very well balanced pump. And to date, we have more than 1,000 installations in Malaysia alone, especially in aircon applications.
Okay,
can, right? So this
the next
when you submit, right,
pump that we are going to talk about will be what we call booster pumping systems.
You have to look at the documents
now
clearly, and also
booster pumping system is not a single pump, but is known more as a package booster set, like what you can see from the pictures here. Now, for many of your consultants or building owners, you just call it booster pumps in the building, but essentially it is made up of a system of a few pumps, a dedicated control panel for that pump, and either comes with a large pneumatic tank or a small pneumatic tank like this, a pressure sensing device, and all these are mounted on a base frame with its pipework.
Yeah, I would say that's the
prerequisite. When are pressure boosting sets required? So the simple purpose is to be able to regulate supply water to a variable demand condition. So such as those for toilets, water fittings, and general use, where the flow demand is always varying. Now, let's say we talk about a public toilet in an office building. So in various times of the day, the toilet can be filled with many people or very few people. So nevertheless, as long as water is used, we need to ensure that all the fittings receive a constant water pressure to ensure a comfortable supply. You don't want a case where when a lot of people is using water, then the water pressure is low. But when nobody is using the water, then the water pressure is very high and wet. You know, when you wash your hands, you get wet also in your clothes. So what we want is a comfortable pressure throughout irregardless of the demand. And that's where pressure boosting sets are designed to ensure this constant pressure. Or perhaps even a multi-story condominium, which is very common, of course, in our city, with many water demand points for each household unit. And depending on the time of the day, the demand of the water will vary according to the number of users or occupancy of the building. So having a pump system with multiple pump arrangement to achieve this variable demand condition, it ensures that each pump runs efficiently while delivering constant pressure supply at all times. So that's what a whole booster set package is designed for. So how is a booster set like Ebara, for example, our UE Mini package? Okay, if you can see from the picture here, it can setup could consist of between anything from 2 to 6 pumps. So in this case, it's a 3-pump system built as a system with full accessories. So you have a dedicated control panel housing all the electrical starters and VSDs, the suction and discharge pipe work, complete with all the isolating check valves and isolating valves, a small diaphragm tank to absorb the pressure fluctuation, a pressure sensor here, and other standard accessories, even for pressure gauge, the suction and the discharge. And all these components are mounted on a steel base frame so that it is easy to be installed and just connecting to the suction and the discharge from the tank to the outlet. So a system like this also uses Ebara variable speed drive technology to regulate or control the pump speed to allow for a very constant pressure. And not only that, it also leads to very high energy savings due to the variable speed operation of the pump. So when the pump reduces its speed, it actually saves a lot of energy, especially in the conditions of low water demand. Now, two main features of a variable speed system that you must know, and this is what we call cascade and alternation. So cascade operation means that the pumps work according to demand condition. So you can see from here, if in a case like this where there are 3 pumps in one system, so the first pump curve will be like this. So that means that any flow between 0 to 100% demand, the first pump will run. But when the flow exceeds the first pump's capacity, the second pump will now come in to share the load, but also maintain the pressure that is set by the controller. And at the same time, when if 2 pumps are already running and the pressure starts dropping, then the third pump will now come in. So each pump is actually working to share the flow rate. And what happens is when the demand reduces, then each pump will start to reduce speed and cuts off. Now this is what we call a cascade operation. Then at the same time, there's also alternating control, meaning that if the first pump has run and stops, the next pump to run will be pump number 2. And when pump number 2 has run and stopped, then the next pump to run is pump 3. So in such a way, it shares equal running hours. And all this is done by the controller of the variable speed drive. So the intelligence of such a system comes a lot from the brain of the system, which is the controller. So Ebara hydro boosters allow for both cascade and alternating control of this up to 6 pumps in one system. Now, finally, we come to the last of the pumps in the building services, and this is where we talk about submersible pumps. And sometimes it's also called sump pumps because they're usually installed in a sump. Now, in a typical building built above ground level, wastewater from the toilets and sinks, bathroom, and all other water fittings flow by gravity and are discharged directly into the main sewer line. which is usually below the ground. So this wastewater is usually channeled to the treatment plants run by IWK. But however, today you have many basement floors and car parks below the building. And waste or drainage water gets trapped if the sewer line is above the floor. So that is where you need a sump to hold all this wastewater or drainage water and allow it to be pumped out. And that is where these pumps are required. So if you look at the construction of a typical submersible pump, you will see here a picture of a cutout where usually the suction will come from the bottom, and this is the pump casing, the volute casing, and the impeller will be taking suction from the bottom and discharging it to the side. And you have the motor. Now this submersible pump will be using what we call a submersible motor, and this is housed in its casing. Okay, so there's usually between the wet part and the dry part of the motor would be a oil chamber, and usually an oil chamber here will have two seals. The bottom seal is usually called a lip seal, which is a simpler seal, and the top part that separates this oil chamber with the motor compartment or the motor area would be a mechanical seal. And there's always an oil chamber here. The reason is because if there's any leakage from the water that is inside the pump, the wastewater, the oil chamber would actually block the water from going into the motor area. So of course you don't want water to actually get into the motor area. So there's double protection here from an oil chamber. And on top there will be where the cable C lies, and that's where the wiring or the cable of the power cable will come out. And even this is a very important design element where a lot of pumps has died or damaged because of a leaking cable seal.
In the coming submission.
So submersible pump that is used for wastewater is usually made of a very heavy duty material, usually cast iron. And in some cases, for example, in corrosive environment, it can also be made out of stainless steel or other more resistant alloys. And even the impeller is made of cast iron for the hard wearing properties. Okay, because this impeller takes up a lot of in simple words, take a lot of shit from the bottom. Okay, when we say wastewater and drainage water, there's a lot of dirty contents inside the water. So it has to handle a lot of this to pump out. So this is a subject by itself which we will talk about in the next few slides.
You have experience on this lah. These are the gray areas.
So importantly, some of the features, as I mentioned, robust and solid construction and the ability to handle solids. Because in the wastewater sump, you don't get clean water, you get dirty water with all kinds of impurities and plastics and leaves and whatsoever that people throw in. So it has to have a good anti-clog design. And that means that the impeller can be made out of many different designs. We call it either single channel, vortex, cutter, grinder, and so on. And with high efficiency motors. And one of the important features is that these pumps needs to be for sewage purposes,
so you can put in a reply
either IWK and SPAN approved. So all our Ebara submersible pumps are SPAN approved and IWK for those above 76 millimeter solid particle.
By the end of this month.
Now here comes a very interesting question. What is the biggest problem for a submersible pump? Anybody has a good guess? Can you type it in the chat again? What do you think is the biggest problem for a submersible pump? Choking, very good. Anyone else? Flooding, okay. Overheat, good.
And lead time about 4 months, 2 months for submission.
One more.
it's okay for us.
Water line falls
2
below
months for
inlet.
submission,
Okay,
then
so
2
that's
months for you
also,
to fabricate and deliver.
I wouldn't say it's a problem, but it's a design issue, difficult to service. Okay, but one of the person just now, I think
Sorry, you're cracking out. Cannot hear you.
Lalita got the answer. It's choking or what we call clogging. But first, before that, let's see the problems here. Now,
So you
I'm
just put
sure
down there
a picture like this sends shivers to you
then
if
we need
you
you
are
to submit
working
the
in a
organization chart,
multi-story
show that
building
who are your
where your
engineers,
precious
who are your
car
P&C
is
teams,
parked
who
at
are
the
your project
bottom,
managers
right?
running this project. Because this is
Or if you
very
own a very,
abstract
very
project,
nice
you
car
need to
and very
have
nice
people to run
expensive
all
car, I
this.
think that's going to be a big problem to you also. And you want to make sure your submersible pumps work properly. Or
FWT, have you
maybe
included
this one?
price for FWT and
Okay,
FAT in
so
your
unfortunately, this one is not pump related. Yeah, this is an act of God already. So this is actually a big flood. So that one no pumps can prevent. So
I think
what
you
we
have to
call
do
an
it
act
this
of
way.
God. Don't
You
blame
have
God
to
though.
put in
Yeah, it's because of
physical
human
FWT
and
to
all
your
the
factory.
too much development
We
and
will
so
have to
on.
test 4 chillers
Now,
together.
as I
But,
mentioned before, the biggest problem
ourselves and the
is
client
what
and
we
also end user
call
will go down to the factory to
choking
witness the first
or
of kind
clogging,
work,
and you can
to
see some
witness and
pictures
test
here. And the design of the pit is very important because when you design a pit for a submersible pump, you have to ensure inside filtered out because it's not a rubbish pumper. Okay, so the pump is actually meant to handle some little solids or impurities, but not, as I mentioned here, a impellers that are able to handle some form of solids particles. And you can see from here, compared to, let's say, a normal standard pump impeller, let's say a clean water pump impeller, which has a very small channel, submersible pump can have different impeller designs. For example, like this is what we call a non-clog and closed impeller, a single channel impeller. Now, what it means here is that the size of this impeller, or rather the vanes, are big enough to let solid particles go through without choking the impeller to a certain extent.
Okay,
And
on the other
a
thing
case like this is what we call a
chiller
semi-open
pump
impeller, so it
optimization
can
system. Have you
even
included
handle
this in your
a
offer?
little bit more than dirty water, but also some form of
Let me
light
see,
impurity like leaves and maybe light fibers
you
and
put it with
plastics and
optional
so
price,
on.
right?
And even in some cases, we have what we call a vortex
350,000,
impeller.
that's I
A
think
vortex
that's a bit
impeller,
too high lah.
you can see from the design here, the
So
impeller
in your
actually
next-
creates a
in your next
vortex
submission,
or a
this
vacuum
post should
principle
not be
where
an optional
water
item.
does not flow through
It
the
must
impeller,
be
but
part
rather
of your offer price.
is the
Okay?
vortex
And you
design
need to relook
allows
into
this
your price offer
pressure
as well,
imbalance
because
to
is too high.
suck the impurity and the water out and flow out rather than going through the impeller. So you can see an example here where even a small ball can pass through the pump by
It's
a
on
vortex
the
section.
PLC, correct? Yep.
So
PLC.
Ebara has one of the biggest range of submersible pump
what
with
you
all
will do
kinds of
is
impeller design.
you have to
So it is
provide
very
the
important that
data
when we
loggers, the
select
servers,
the
all the
pump,
hardwares,
then we will
and
actually
the
ensure
programming
that
also run by your side.
for
We
what
have
kind,
provided
or
you
rather
the
we will
sequence of
definitely want to
operation
know
in the
what
email
kind
to you.
of liquids
All
you are
the
pumping
criterias written in the
before
sequence of operation
we
has to be
select
applied.
or design the right
And
pump for your
all the
application.
wildings will be
So you
by
can see
the
here from
contractor. The field sensors will be by every
could be a semi-open or could be a non-clog vortex impeller, or even a grinder type of impeller which cuts these solid particles and it goes through, so many others. So this is a subject by itself. We will not cover too much detail here, but if you want to know more, then we can always answer to your query later.
And as far as your price is concerned,
and not only that, but in today's buildings, we have what we call ejector systems, which is an all-in-one design. And this is very, very good, what we call plug-and-play solution, where compared to having a conventional pit, which usually will result in dirty, unhygienic conditions at the basement, and you have all kinds of pests, cockroaches, rats coming in and out. Ejector system concept like this provides a clean and hygienic solution. And because it's covered, there's no smell whatsoever, and easy to clean and maintain. So it's very clean, and it does not create, the kind of smell and let's say all the pests that will come from a system like this. And not only that, but it also prevents ingress of foreign materials, because if you have a sump pit in the basement, not only you get water, but you get all kinds of other rubbish that goes into the pit when people just throw it in. So you can see some of the ejector system examples here, and a few examples of installation that we have done recently for a project in Penang for a hotel. And you can see that with the pit, we can actually put an ejector system just inside, and it's a very clean solution. And even one more in a small room. So it is a self-contained system. So there you have it. These are the 5 most common pumps that are used in any buildings. And if you walk into the pump room of any building, you will probably see these pumps in action. It could be the multistage pumps or the end suction pumps, or the split case pumps, usually on at the roof or at a separate area near the chillers, and pressure booster sets and the submersible pumps. And Ebara is a very wide range of pumps, and we are able to offer a full range of pumps for the building services application. Now, finally, not only are we talking about pumps, today, as we look at sustainability and green buildings and development, and how pumps can contribute to these, you will be pleased to know also that Ebara has a very extensive range of green certified pumps. And these are basically pumps that are GBI compliance, and is recognized not just by GBI, but also by the My Hijau program, which is administered by the Malaysian government. And we have acquired the certificates for all the range of pumps in the building services application. And with these pumps, whenever you use these pumps for your project, you are able to get incentives from the government if you join this, what we call the Malaysian government green procurement program, where your client, for example, a developer, will get tax incentives out of using green certified pumps. So whether it's for government building or private building, you have both the GGP program, and for private, you have this GVP program. Okay, if you want to know more, send us an email, and we can let you have some info on this program. So finally, not only is Ebara a dedicated and professional pump supplier, but also some of the various quality certifications that and approvals that we have in our operations and products. So you can see that not just the ISO, but also SIRIM and SPAN certificates for all our products, as well as My Hijau. And many of the clients, whether it's JKR and Petronas, Selangor, and so on, we have the approvals for these customers to use exclusively for their projects. So, in closing, as we end this presentation, if you have any questions at all, as I mentioned before, just type it there, or if you also want to ask, you can unmute yourself at the end of the session and we can discuss about your particular inquiry. And if you are shy, then just type your questions on the chat column and we will consolidate it and then go through it after the session, okay? Right after this. Now, we also would like you to just fill in the survey for us to gauge the effectiveness of this webinar. So you can see the QR code on your screen. So I guess you all are familiar with how to use QR codes now with the Selanka. So just scan this QR code with your handphone and it will lead you to our survey questionnaire. And from there, we hope that you can just take a minute to fill in the questionnaire and it will be automatically sent to us. And at the same time, for those who are using your handphone, you cannot scan, then the link is created in the chat column now by Miss T, and you can just click on that and it will also lead you to the questionnaire. Okay, so we hope that you can just fill in this questionnaire quickly. So once again, some upcoming webinars. I believe many of you all have also received news on our second and third topic, but for those who have not, then our next topic on Friday, 19th of February, same time, 3 o'clock, we will have a topic on efficient pumping methods for high-rise buildings, where we will discuss on what are the good ways of having a efficient design, especially when you are using pumps or designing for pumps in a high-rise. And subsequently, for the last week of February, we will have a session on some of the good installation practices as well as noise control solutions in buildings. Okay, so again, as the MCO progress, then we will add on more topics and keep you informed.
Okay.
So once again, these are our contact details, and if you need to know any information regarding our products or require any assistance in your pumping design, just call or send us an email, and definitely we will get back to you. Okay, so whether you're from Kuala Lumpur or Johor or Penang or even East Malaysia, we also have our branch officers to help you with the pump selection. Okay, so before we end and move to our next Q&A session, let me also take this opportunity to wish all of y'all out there, especially the Chinese, a very happy Chinese New Year, and please don't spend it in the Pasar Malam, okay? Spend it with your loved ones at home. Thank you very much for joining this afternoon, and we will now next move to the Q&A session.
The LED, how is the LED? Must be 20%, right?
This one is our contract.
It's a Walloon standard, right?
It's a client standard.
Okay, so
according to
now we are just waiting for all the questions to be consolidated. Okay, we have it now. So we'll try to answer these questions one by one. And hopefully be able to at least solve some of the issues that you have. Okay, let's go through the first questions. The first question, yeah. Hi, wonder if I have an expansion tank at floor above my storage tank. The water supply will need to pump from storage tank to it. Transfer pump or booster pump should be used. Okay, for water transfer, meaning that if you are pumping to fill up a tank, then you should just be using transfer pumps. Okay, booster pumps are for pressure boosting to toilet fittings where you have variable demand. transfer pumps are used to just fill up tanks, because when you fill up a tank, you just want to pump a certain flow rate to fill up that particular tank. So you don't need, let's say, pressure control. What you need is to ensure that the pump actually have the head enough to pump water to that tank. So I hope that answers your question.
On the 11th, can you do that?
What is the highest transfer pump could pump up? Well, our vertical multi-stage pumps, like I mentioned earlier, can easily go up to 200 meters head, and that's easily maybe, I would say, 40-50 story building. But in such cases, normally you would use intermediate or rather two-stage pumping, and there are good reasons for that. We will cover that in our next topic on high-rise pumping applications. So, but to answer your question simply, vertical multi-stage pumps can easily do up to 200 meters head if you need that kind of pressure.
Thank you very much. I have nothing else.
Number 3, UL listed pump will be provided with certificate for that particular pump. How about LPCB? Okay, here you are asking about our fire pump range. We have pumps that are compliant to LPC standard. In fact, our GS series fire pumps are complying to LPC, but they are not listed by LPC board. So there's a difference between complying and listing. Yeah, so complying is basically you are meeting the specifications of that particular standard. But listing means you are having a certificate by a certain approval body that specifies that your pump is certified or has met that certification. So in such a case, we did not send our pump to LPCB board simply because you know, the demand is very small for LPC listed pumps in Malaysia. But if you say that if you are designing a fire system based on the LPC standard, which means that you're following the OH ordinary hazard standard, whether it's OH 1, 2 or 3, then our pumps comply to that standard. Okay, so I hope that answers your question. Number 4, what is the con and pro for vertical versus horizontal pumps? Okay, there are many advantage and disadvantage or cons and pros. I will just list down very quickly a few. Normally, of course, a vertical pump takes up less floor space, so that's one advantage. Secondly is that a vertical pump in most cases do not need any alignment because of the vertical shaft compared to a horizontal pump, for example, like a horizontal split case or end suction pump, where the motor and the pump are two separate shafts and it's joined in the middle by a coupling. So when the motor is spinning at, let's say, 2,900 RPM or even 1,500 RPM, the shaft has to be perpendicular to, you know, to each other, the pump shaft and the motor shaft, or else even if by 1 degree off alignment, then you will start to have misalignment issues like vibration, noise, and so on. So in such a case, a vertical pump always has a better advantage from an alignment point of view. Okay, so two main advantage: space saving as well as alignment, or rather you don't need to align a vertical pump. Okay. Number 5, what method to reduce structure noise issue at brake tank transfer pump? Okay, so very good question. We will cover this on our third topic, which is noise control. Okay, there are a lot of ways and also a lot of reasons why an installation make noise. So all this we will cover at the third topic. So stay tuned for that. Yeah. Thank you for your question. So number 6, thank you for providing. Okay, thank you very much for participating. So you have 2 questions regarding submersible pump 30 kilowatt. what is the
based on your
lifespan
previous
if it's not
submission,
maintained at all?
we
Wow,
have
very, very good
tabulated a
question.
list of clarifications, as well as
I
recording
cannot
and
give you
also
a
the
definite
sequence
answer for
operations
this
given to
because
you. Have you
if
received
you
it?
are talking about a submersible pump,
Yes.
and
You mean
it
the-
depends again on the environment of the pump.
the
It could
whole
break out from the pump could be destroyed by day 2 if you don't use it
So I will
properly.
go
You
through
know,
on
if
clarification first on
if
the
it's not
commercial
pumping
side,
like
and
some
then
of the pictures
on the
that we
south
show
we'll
you,
go to
it
the
is
technical
pumping
part
dirt
review.
and
Okay.
trash, which is not
Okay,
designed to,
first,
then
the
it can
delivery,
spoil very
unloading, and
fast.
hoisting.
So I
Okay,
wouldn't
it is made
be
to
able
clear
to
that the
answer the
delivery
lifespan,
and
but
unloading
importantly,
has been
when
at
you
the
use
site,
a
and
pump, you
hoisting
must
has to be
maintain it.
done
Okay,
by
a
our
pump is a
civil
running
contractors.
equipment,
But
and
it
you
is
must have a
we put it
maintenance
there
plan,
that we
whether
want you to take out the
from your
responsibility
client
to monitor and also
point of
to give
view, they
approvals
must
to
be
the
able to have
SCAV
a
contractors
maintenance plan for these pumps.
before they
And that means for
hoist your
submersible pump, you
equipment
need
to the
to
designated
at
position,
least
which means
ensure
that
that
they need to submit
it
the
is
MEDSYS
taken out
standard to
every
you,
year to
and also
be
to show you
inspected,
that
to be
the right
cleaned,
equipment is being
and to
used
ensure
hoist
that your
equipment
pit, very important, your
before they can
pit
do that lah.
is
Otherwise,
not,
if
fill up
if
with
there
all
is any
kinds of
damages
rubbish
to
and
the
so on,
equipment
which will affect the operation
when they
of the
hoist
pump.
it, prior
And
to any
Ebara
of
pump
your
maintenance
approval,
requires
you
special
have a
training
gray
cert.
agreement
No,
gray
but you
area for
definitely
equipment
need
lah. So if you
training
can, we
to
want you to
maintain
take
any
insurance for
pump.
hoisting also. Can you do
So
that?
usually our service center will be the place for you to send the pump to. And if you are looking at maintaining these pumps yourself, if you, let's say you are coming from a facility management company, then it will be best to have at least some form of training.
So
Now we
when
have
you
many
deliver
what we
on
call
site
third-party
on the lorry,
contractors
you have to unload it.
that maintain
You have to
our
unload
pumps
it
or
to the
service
ground,
our pumps.
correct or not?
And for example, like many
then
of
after
the
that,
pumps that are used in
SCFD
IWK
contractor
treatment
will use their
plants
crane
are
to
maintained
hoist
by
it
third-party
into the chiller
contractors
plant.
that work very closely with us. So they have their workshops to maintain or rather to service these pumps.
No, because
Okay, and
these
usually they
tenders,
are
right, it's actually a
experienced and
supply
trained
install and TNC lah. You will be like
for
a
handling these
subcon to
pumps.
Walloon. Okay. So
Okay,
you're just a
so
supplier
number
to
7,
SCFD
what is the small
So we
nipple
want
at
you
the
to take out
bottom of the end
responsibility
suction
of
dust?
delivery, unloading, and also
I'm not sure which
monitor
nipple are you
hoisting
talking about,
process.
but that could be a drain plug.
This is to avoid any
You
conflict
have
between,
probably
you
two,
know, when
apart
they
from the
hoist
suction
it,
and discharge
and then, your side is not
outlet,
aware that
you
how
have
they
a,
hoist
if
it,
you say it's
and
at the
then after that,
bottom
if
of
there is
the
anything
pump, that
happen
means it's probably just a drain plug.
let's say the
If you
crane
need
is
to,
not
for
enough
example,
load to hoist
take out the
equipment,
pump
crane turn over your
or
equipment,
remove the pump, then you need to drain out
damage,
the water.
who's
So
gonna
that's
pay
what
for all
the
these
plug
things?
does. But if you see a plug on top of the
in my
casing,
tender
that is
correction
usually the
3
priming
and
plug,
4,
and that
we want
is
you
meant
to
to
actually
remove
put in the
air.
insurance for this
That
and
means
take up
before
the
you start the
responsibility as
pump,
policeman to check them.
you have to allow the pump to be
Allow them
filled with
to
water fully, and you do that by
So you
actually
have the authority on this lah.
open that plug
Because
up to
there's been
allow
quite a
all
lot
the
of
air to
cases on this
escape
already. We want to avoid this.
when water is filling up the
Okay.
pump
The
before you start the pump, so that the pump does not get into airlock.
During hoisting.
We will cover that also a little bit
I
more
believe-
in
yeah,
the next
yes,
topic
correct. You're
on
right. I
installation
believe we have
and
insurance
priming
covered.
and so on.
We usually cover
Okay, so number 8.
delivery to site.
What are the effects of using a split case pump for application
SCFD.
below the recommended flow
That's
rate?
why
Usually.
we are highlighting this.
Now,
We're highlighting this. This is
normally,
so far,
every
we want to
pump
improve the
will
situation.
have what we call
We
a
want you to improve that as
BEP,
well.
which is the best efficiency
I don't
point.
think-
So if you look
I
at
don't
the
think it
pump
will cost a
curve,
lot of money lah.
it will state,
We already
where are
have the insurance
the
for that
maximum
delivery
efficiency and the range of
I need to talk
the
to
good
the
efficiency of that
logistics
pump, and that
Yeah, no
means
problem. You
that
can just
was
put it,
that
reply
is
us
where
on
the
tender
flow rate
correction
and
to
the head
qualify
of the
yourself,
pump
okay?
is designed for.
Okay, the next
Now,
item
in a
will
lot
be
of
on the
cases,
testing
you
and
can
commissioning.
have
So in this project,
pumps
our
that are
MEDSYS
running,
has
let's
a very
say, to
special
the right
feature
side
which
or to
is
the left side of the
where
curve,
we need you to have a
which
full-time
is
TNC manager
not at its
to be there
BP.
to-
Well, in that case, there are
monitor
many
and
ways
control the entire
to
situation,
remedy
also
such
to
a
upload all the required
case.
testing documents,
In
testing
some cases,
script,
if
and
it's
also the
running for a
testing
short
result.
time, it's
in the current
reduce. So the pump will
have your engineers running around, then you will have your drafting side or installer. The delivery time. So now we are in the month of February. Hopefully by the end of February, we will have to close this tender, which means that you will have 6 months from the end of September.
that's just let's say observations that we will get if we use a pump, or rather the flow rate is out of the stated design
you will need
of
your
the pump.
equipment on site on the 1st of September.
Okay, number 9. Will turbulence be a big factor in the efficiency of the pumps or the work rate, which might affect it? Very, very technical question. Yes, turbulence will affect the suction of the pump. Now, turbulence can be caused by one of the main reasons is the way the suction pipe is designed into the pump. For example, if you have an elbow right before the pump inlet, this can cause turbulence when water actually enters into the pump. So what will happen is that, you know, water also needs a very good laminar flow. But an elbow, if it's a very sharp elbow, can cause turbulence of the water when it goes into the pump, and that will increase the MPSH of the pump, which means it will actually cause poor suction of the pump, and that may affect the pump operation. Well, not to a very big degree, but it will affect in some way. And if it, again, if it's a system design problem, then eventually the pump will lose suction.
With the client.
Is there a way to reduce it? Yes, definitely. That is to redesign or to change. You cannot do anything to the pump if the turbulence is already caused. Usually the turbulence is not caused by the pump, but by the either the pipe or the suction pipe could either be smaller than the inlet of the pump. Then it's also one issue. So there's nothing that you can do on the pump side. You have to change your suction side of the pump. Number 10, booster pump with VSD. Does it require a pressure tank? Yeah, this is a very, I would say, confusing.
Give us a clear picture on how to do this.
Not a dilemma. But a lot of people have been asking, do we need a pressure tank when we use variable speed drives booster sets? Now, if you compare it to the old conventional pneumatic systems, you need a very big tank because you want to control the start-stop of the pump. So the pneumatic tank actually acts as a buffer to prevent too much start-stop. Now, in a variable speed system, the pumps do not start and stop anymore, but adjust the speed. So that means the function of that pneumatic tank is greatly reduced. But we still put a small pressure tank. The reason is to absorb some pressure fluctuations in the water itself, because we have a pressure sensor at the discharge pipe, and that pressure sensor reads the discharge pressure of the pump. So we would like to have a very stable signal from the pressure sensor to the inverter or to the controller of the inverter. And usually the small tank is needed to cushion the pressure fluctuations or shocks from the pressure fluctuations that is caused by the pump. So that's one of the main function of that pneumatic tank, or rather the diaphragm tank. So we don't need a big one because we don't need to control the start-stop of the pump anymore, but we still put in a small one just to absorb the fluctuation of the pressure. In terms of sizing, usually we just follow the standard sizes for a certain, let's say, small flow rate. We could be using we could use just a 24-liter tank. But if let's say a flow rate of above 30 or 40 meter cube an hour, then we would use up to a 100-liter tank. So bigger flow rate means we use a slightly bigger tank for that purpose. Yeah. Okay, so number 11, will the concrete inertial block spring isolator from acoustic affect the performance of the pump? To answer the question simply, no. In fact, it actually improves the performance of the pump by absorbing the vibration of the pump, yeah, and also by giving a very solid foundation. So once again, this question, very good question. We will go through it in the topic 2 under installation of the pump, yeah, the purpose of having inertial block and spring
isolators. It become a prerequisite already for you.
Number 12, what is the minimum sump pit for submersible pump? Okay, I just got this question just now, so I don't know whether this is the same engineer that asked me this. Now, for submersible pumps, because of the way it operates, your pit sizing is very important. And the reason is because unlike a normal cold water pump where you have a motor on top and the motor is cooled by the fan on that motor, yeah. So when you call it a TEFC motor, it basically means totally enclosed fan cooled motor. So a submersible pump, the motor has to be cooled by the liquid of the surrounding. And I mean, basically, if the pump is inside the pit, then whatever liquid that's inside the pit is cooling the pump's motor. So it is important that in the relationship between the cooling and when the pump is running, the pump, as much as possible, have to be submerged. Now, of course, the function of the pump is to drain off or de-water or clear off the water. So that means the water level will go to the bottom, right? So that is where your pit sizing is important to ensure that the water that is being cleared off does not exceed let's say around 3 to 4 minutes of the pump running, because then the motors will tend to get very, very hot because there's no water cooling the surrounding, and then it can overheat and damage the pump. So in correlation to that, your pit sizing has to take into account the depth of the pump as well as the volume that is needed to pump out. Yeah. So there's a formula for that on sizing of this type of pits against the flow rate of the pump. So if you need that, then we can send it to you. So I hope that gives some at least basic information on this method. So question 13, for submersible pump, if allow the solid particle to go through, it can pass the pump, but after pass the pump, it will cause clogging to the pipe. Yes, to a certain extent, or the pump will refine the solid waste into a certain. No. The pump cannot do anything to the rubbish. Now, unless you talk about cutter or grinder pumps, you know, just now we show you an example of a grinder impeller where it cuts the waste that goes inside the pump. So if you have this type of pump or impeller, then it will actually cut off all the particles. But a normal pump cannot just refine the solid waste. Yeah, the impeller does not do that. It basically just allows the particles to go through the pump to prevent clogging. Okay, so number 14, can submersible pump handle plastic material? Well, it depends again on how big or how small. When you say plastic, are you talking about like, the plastic wrapping and all that? If it's very small, then no problem. But you have seen the pictures of the slide earlier when too much goes in, then of course it gets clogged. So if it's just 1 or 2 or 3 plastic pieces and it's small, usually the pump is able to pump through. Now we are talking about pumps that have what we call an open impeller, yeah, or a single channel impeller. But if you are talking about a very small submersible pump, then it may not be able to handle. So again, it depends, yeah, on the type of pump and impeller that is that is inside that pump. Okay, for number 15, for lake or fish pond where the base is mud, how the pump installation is recommended? Is submersible pump recommended? I would say no, because remember that a pump is supposed to pump some water and a little bit of dirty water, but not a mud pumper, yeah? So that is not the application of a submersible pump. Once you pump a lot of mud, the pump will definitely get clogged or just jam. So if you have such a situation, then it is very important to allow or to design a pit where the mud, as much as possible, is not inside the pit, because you must prevent the pump from pumping too much mud. Okay, so remember again that the pit design is very important.
You have your heaters, also your
if you have a muddy base, let's say a river or something, then you have to have a channel that will you know, like intake,
make sure that
where you can actually isolate the mud from the pump, or else you will have endless problems of the pump being clogged.
No, then we
okay,
you have to pull from.
So is submersible pump recommended? I think I've answered that question. Have an intake, yeah, where you can isolate the mud from the water, because your main function is to pump water out, not mud, yeah.
But you have to let us know what
16. How to tackle site condition that have pump room above ground that give MPSH to the pump. Is adding a foot valve alone is sufficient, or need to add a priming tank? Okay, very good question. You are asking about a negative suction application, which means that the water is below the pump. Now, in such a case, if you have a pump that is on top of the water level, then the first thing you have to ensure is the MPSH required versus the MPSH available. Now, we did not cover this in this topic simply because it is you need to actually have the understanding of MPSH itself, and we actually covered this in our last webinar series. But basically, you need to know what is the MPSH available against what is required by your pump. So if your pump requires, for example, 4 meter MPSH, but you can only give 3 meters, okay, by calculation, then that means the pump will have suction problems. So even if you put a pump on top, then the pump will not be able to take suction. Now, supposing if your MPSH available is more than the required, then the pump technically should be able to take suction, but you still have to have a foot valve, and the reason is because you have to always ensure that when the pump stops, the water does not flow down to your sump or to your water containment, because the pump needs to, a centrifugal pump basically needs to be primed at all times to ensure that it takes suction. Because if you run a pump dry, then the pump will never be able to take suction. Okay, so that is the let's say weakness of a centrifugal pump. You cannot just run a pump without priming it. Okay, do we need to add a priming tank? It depends again on your application. For fire systems, priming tank is a must because it is in the regulation, and you want to ensure that when the pump starts, no matter how you have water, so a priming tank is needed. In some cases, I've seen that people do not put a priming tank, but if you want a straight forward answer, yes, a priming tank is always better because that ensures that the pump is always primed before you start. Number 17, how to determine the capacity of the submersible pump for basement car park flooding prevention. Okay, I have answered that earlier, and again, same answer. There's a formula for determining sump sizes. So just send us an email and we will send you the formula as well as the write-up on that. Okay, so question 18. Can share some product related to self-priming pump. What is the maximum capacity does Ebara have? What kind of price difference from normal end suction pump? We have a range of self-priming pumps. Again, it depends on your application because different application would use different type of self-priming pumps. Some are meant to pump dirty water. Some are meant to pump clean water only. And also there are very small self-priming pump, but there are also bigger ones. So let us know in more detail, for example, like, how you are installing it and what is the flow rate and head and so on. And then we can actually size for you the right pump. Number 19. What kind of price difference from normal end suction pump? Well, definitely a bit more expensive, simply because an end suction pump is quite a straightforward pump. But a self-priming pump has another, let's say, chamber, to expel the air and all that. So the volume of such a pump is also less. So that means basically the cost is more. So it depends on, again, the model and the flow rate and the head. Yeah. Okay. So number 19 is a VSD pump required power factor correction. Very technical question. Usually power factor is related to your power supply, and usually for VSD pump, because of the fact that it is controlling the frequency of the power supply, normally you do not need to make this as a point in your design. Because what a VSD does is to actually adjust the frequency of your supply to alter the speed of the pump. So I don't think a power factor is an issue. And anyway, most of the time, I think the power supply in Malaysia has quite reasonably good power factor values. So it's not a major concern. If you are in a country with very backwards power supply system, then this could be a concern. Number 20, can share the formula to calculate. Okay, so we have answered that question also. Please send us an email. We will send it to you. Usually, okay, question 21. Usually, how is the warranty for the pump? Normally, we would give standard manufacturing defect of 1 year from the date of supply. In some projects, depending on the project, then we could extend the warranty and also the servicing contract and so on. So to answer your question simply, it's 1 year warranty. Yeah. Okay, question 22. Compare between multi-stage end suction and split case. Which one is less impact by cavity at impeller surface during pump operation? I believe you are talking about cavitation, yeah? I would say that a split case has probably the best MPSH value and also the best suction capability. As I mentioned earlier, a split case has a double suction, which means that it is able to take suction from both sides of the impeller. and that will result in a much better suction compared to a multi-stage or end suction pump. Yeah, and if you just compare on the pump curves itself, the MPSH value, you will see that normally a split case pump has a much lower MPSH required than other pumps. Okay, number 23, from operation point of view, why a pressurized pipework needs a jockey pump in the case of fire insertion? Okay, why need a jockey pump? Well, the idea is that in a fire system, your main duty as well as your standby pumps are usually bigger pumps. So depends on whether it's a sprinkler system or a wet riser system. The pump could be as big as 15 kilowatt, 20 kilowatt, 22 kilowatt, 30 kilowatt, and so on. So a jockey pump function is just to ensure that the pipe is pressurized, so that your pipe is always pressurized. In case a fire happens, then when your sprinkler pops, then the pressure is released immediately. Now, in such a system, there's always some small leakages that could reduce the pressure inside the pipeline. So what happens is that because your fire system or your pressurized pipework is activated by pressure switches at the pump site. So what you don't want is, because of a small leak, a big main pump starts to run, yeah, and pressurize up the pipework. And if this leak is constant, then your main pump will keep turning on and off just to pressurize. So the idea is that a jockey pump, which is a much smaller pump, and it could be sized usually 5% of the total flow rate, is used for this purpose. So whenever there is a leak where the pressure starts to drop, then only the jockey pump will run to press up the pipework pressure. So that's the main function. Okay, so B, based on your experience, what kind of interval is considered normal for the jockey pump? I'm not sure what you mean by intervals here. Are you referring to the flow rate or the start-stop? I believe if you're talking about the flow rate, then it's probably 5% of the total flow rate of the main pump. That would be good enough. There's no formula for this. Usually it's just based on what you feel would be the leakage rate of the pipework, of the pipeline. Yeah. How pumps are certified as green? Okay, now basically when we talk about green certification, like MyHijau and MGBC standard, they have set a criteria where the pumps needs to show a very good level of efficiency compared to other type of pumps, and also having a certain manufacturing standards that are complying with green standards. Yeah, and that means that either the factory is a ISO 14000 standard, kind of manufacturing, or the company has some quality systems that meet certain green standards. So from that perspective, the bodies like MyHijau and MGBC will then classify these pumps and certify these pumps as also green. So that's just to answer your question simply. So then they issue these certificates that show that the pumps are approved and recognized by them in meeting their standards. So we have all the certificates for MyHijau, and and some of our pumps have what we call GBI credits for green building. No certification from Jabatan Air Sabah. Yes, we have. If you really want to see it, please again drop us an email. I believe we are certified, or rather approved, with Jabatan Air Sabah. So thank you from Sabah, and to Sabah we love. Yeah. Number 24, the Ebara pump has certification with Bomba. Okay, good question. Now, Bomba does not issue any form of certification. So they do not say that this brand of pump is approved and that brand of sprinkler is approved. As far as we know, Bomba does not do that for any equipment. But the latest standard that has been issued out is that they require compliance of fire pumps to MS 2616 standard and ISO 9906. So basically these two standards, as long as your pump meets these two standards, that means Bomba should be approving it. So both all our pumps meet these two standards. Yeah, ISO 9906 is basically a standard on how the pumps are tested, and MS 2616 is basically a standard on the requirement for fire pumps in terms of the selection and the duty point and how much access it must be able to cater to and all this. So our